Welcome to the simple harmonic motion of a pendulum video. In this experiment, we will be using a pendulum to find the acceleration due to gravity, investigating the phase relationship between angular position and angular velocity, and determining the effects of changing pendulum length and mass.
We'll begin by setting up the equipment. Mount the rotary motion sensor on the post and attach the angle indicator, the rigid pendulum arm, and the mass. Ensure the angle indicator reads 0 degrees. Plug the sensor into the data acquisition interface. Measure the distance from the pivot point to the center of the mass.
Open Capstone and set the sample rate to 100 Hz using the controls at the bottom. Also, create a graph of angle versus time.
Set the pendulum in motion, making sure to keep the angle small. A good rule of thumb is to keep the amplitude below 0.2 radians. Record at least 20 oscillations and then press stop.
Change the effective length of the pendulum by moving the mass. Measure the new position of the mass, remembering that you still need to use the effective length formula. Repeat this for at least 10 different pendulum lengths.
Remove the mass and measure the distance from the pivot to the center of the rod. You'll need this to calculate the effective length of the pendulum.
In exercise 3, we'll be plotting angular velocity versus angular position and using the shape of the curve to deduce the phase relationship.
Create a new capstone page and make a graph display. Set the y-axis to angular velocity and the x-axis to angle, and either pick your favorite run or record a new one. This will show a Lissajous figure to compare to the manual.
In exercise 4, we'll be changing the effective value of g by changing the angle for the rigid pendulum. We will use the periods of oscillation to calculate g.
Change the tilt angle by adjusting the variable angle clamp. Note the angle displayed by the angle indicator.
Start the pendulum in motion, again using a small oscillation angle. Press record in Capstone. Record at least 10 oscillations. Repeat this for at least 10 different tilt angles over a wide range.
In exercise 5, we'll be seeing the effects of varying the pendulum's mass while keeping the effective length constant.
Remove the mass from the pendulum.
Start the pendulum oscillating at a small angle as usual. Press record in Capstone and record at least 10 oscillations.
Add one mass to the pendulum, ensuring that the effective length is kept constant. As before, collect at least 10 oscillations of data.
Continue adding masses while keeping the effective length constant. Repeat the measurements for a total of 5 distinct masses.
If you haven't already done so, weigh the rod and each of the 4 masses. You will need all of these to calculate your effective lengths.
Thanks for watching the simple harmonic motion of a pendulum video. If you want to learn more about pendulums, drop by any time for an interesting back and forth discussion.